Welcome to Maths for You YouTube channel. A past question on pure mathematics. A curve has equation y equal 1 over x plus c, and a line has equation y equals cx minus 3, where c is a constant. Find the set of values of c for which the curve and the line meet. Okay, let's start with part 1. The curve equation is y equal 1 over x plus c, and the line equation y equals cx minus 3. For them to meet, this should be equal, the 1 over x plus c equal should satisfy each other, cx minus 3. From that, for the left hand side, LCM x, then it will be 1 plus cx over x equals cx minus 3. Cross multiplication, 1 plus cx equals cx squared minus 3x. Rearranging it, cx squared minus 3x and minus cx the other side. Take it to the other side, minus cx and minus 1 equals 0. So cx squared minus 3 plus cx minus 1 equals 0. This is the quadratic equation in x. So this tells the line and the curve meet at two places. Well, it could meet two places, providing because we have c constant. So in order for this the line and curve meet at two places because quadratic equation, the discriminant of this quadratic equation has to be greater or equal. Therefore, it gives you two roots and two real roots. So I just wrote it here. For the curve and line to meet, it should take a real value. In order to real value, the discriminant has to be greater or equal 0. Discriminant is b squared minus 4ac. You say a x squared plus bx plus c equals 0. The discriminant is b squared minus 4ac. So if you do that, if you compare that, x squared plus bx plus c equals 0, compare this equation we have, the discriminant is b squared, that is c minus 3 plus c squared, minus 3 plus c squared, minus 4 times a is c times c is minus 1. So the first part is 3 plus c squared plus minus minus plus 4c. And if you could expand it, square it, 3 plus c is a standard square, 3 plus 6c plus c squared plus 4c. That becomes c squared plus 10c plus 9. So this is the discriminant in c, and again the quadratic equation. So what we need, what we said is the c squared plus 10c plus 9 have to be greater or equal for the line. That's what we see here, for the line to meet and x get the real values. So two real values that should be greater or equal. Well, equal is same value. If it's a different value, greater, but real values. So to x get a real value, c is c squared plus 10c plus 9 have to be greater equals 0. And c squared plus 10c with 9 plus 9 can be factorized. It's simply the cross that cc and 9 and 1. So c plus 9, c plus 1, the factors of that quadratic equation in c. So greater equals 0. There is our equation in inequality. So c plus 9 greater than c. So the two-way. So for these two multiple to be greater 0, both of them positive or both of them negative. because of this, otherwise, it will give you the a negative value. So for them to positive, both of them positive, or both are negative, negative times negative is positive. So c plus 9 greater than 0, c plus 1 greater than 0, just one case, let's take one. And from that, c greater than 9, c greater than 9. From the other one, c greater than minus 1. So c greater than minus 1, if it's c greater than minus 1, it definitely has to be greater than minus 9. So just leave this out. So all we need this one. So c greater than minus 1. If it's c greater than minus 1, it definitely has to be greater than minus 9. So that doesn't make any sense. So the next one, both less than 0, less than equal 0. So c plus 9 is less than equal 0, c plus 1 less than equal 0. So from that, c less than equal 9 and c less than equal 1. If the c is less than equal 9, it definitely would be less than equal 1. So that doesn't make any sense. So it's just only this one. C is less than or equal 9. That covers the less than equal 1 will be covered. If it's less than equal 9, that has to be less than equal 1. So the two values we have, two values c will have, either c get greater than minus 1 or less than minus 9. So I put a little sketch saying that is minus 1, minus 9. So less than minus 9 this way, and or greater than minus 1 and this one. So in between, it shouldn't take. If it does take it, it won't be greater than or equal 0. The discriminant cannot be greater than 0. That's what I just put. C cannot be less than or equal minus 9. C cannot be greater than or equal minus 9, and here C cannot be less than or equal minus 1. So it's just this little area. It won't take the value between that. It doesn't make sense. Well, it wouldn't give you the discriminant greater than or equal 0. So that values here, we have found the values, two values. One is greater than minus 1, greater than or equal minus 1, and the other one less than or equal minus 9. Okay, part 2. The line is a tangent to curve for two particular values of c. So we have actually just area of two values. One greater than minus 1, less than minus 9. So it's not two values, two range of values. Particular values of c. For each of these values, find the x-coordinate of the point at which the tangent touches the curve. Right, now, it touches the curve. So not meet the curve and cut the curve in two places. X have two values, but this is touches it, touch the curve. If it touches the curve, that discriminant is equal 0. So the discriminant, which is we found this c plus 9, c plus 1 equal 0. That is the discriminant equals 0. Therefore, same value. If touches mean it should be one value for x and for a particular c value. So that equal. Say I just wrote that curve again, line again. For the line to be tangent, touches the curve, x roots to be same. So x roots should be same. If it's therefore, discriminant equal 0, as I said before. So first value c1 and c2. There are two values. That is what they said, two values in that question. It says the line tangent to the curve for two particular values of c. That two particular values are, when discriminant equals 0, if you do that, then c equal 1 and c equal 9. These are the two values. So let's say c equal where is it? It's minus in it, sorry. c equal minus 1, this is minus 1, right. So c equal minus 1. If you substitute that c value to that main equation, the x quadratic equation, that gives us x squared plus, when you do the work, and x squared plus 2x plus 1, that is x plus 1 squared equal. So therefore, the same root, minus 1, is only one value to get it. So this is for c equal minus 1. And then again, c equal minus 9. Again, when you substitute that minus 9 for c, that become as 9x squared minus 6x plus 1. That is 3x minus 1 squared. Again, x equal 1/3 for c equal minus 9. So those two values, c equal minus 1 and c equal minus 2, those two values are the discriminant equals 0 because of the line is touches this. When line touches this, c taking two values. For one value, it is x equal minus 1. For the other value, x equal 1/3. So that if you read that question again, two particular values of c, which is minus 1 and minus 8. For each of these values, find the x coordinate of the point at which the tangent touches. That's it. So x coordinates are two x coordinates values is minus 1 and 1/3. Minus 1 when c equal minus 1, and 1/3 when c equal minus 9. Thank you. Please subscribe the channel and share the contents, share these answers with other students and friends. Thank you.